Hello everyone, welcome to my channel. My name is Bhakti Gundewar and today I will discuss about the new topic in measurement and transducer system, that is the flow measurement. So what is the flow? So the objects like potato, onions, they are solid. Why? Because they remains their shape when they are thrown. And other hand, air does not remains their shape while moving in and out of our lungs or moving flow from one place to another place. So furthermore, we can say the matter which is not a solid is the fluid, and the main property of fluid is they can flow. So fluids can move, and when they move they change their shape and volumes, but while moving they are means their mass remains same, they are not changed with respect to time or space. So flow definition, we can from this we can define the flow definition is the volume or mass quantity of fluid that flows from section of pipe per unit time. So now flow measurement. So we have seen about the flow. Now measurement means it is the process of measuring the fluid in your plant or industry, or we can say it is the process of measuring the amount of fluid flowing through a given point in a given time period. So instrument which is used to measure flow rate is known as the flow meter. And what is meant by flow rate? It is the volume of fluid that passes through given cross sectional area per unit time. So now there are types of flow. So there are mainly 6 types of flow, and they are divided according to their condition under which the particles of water unite and move. So there are few reasons behind the flow occurrence. Means first one is if difference of energy between two distant point, that time flow occur. Otherwise due to pressure difference between two ends of pipe, or one more reason due to the difference in datum energy and the pressure energy in case of inclined pipe. So I have told about flow types. Means there are 6 types of flow. One is first one is the second steady unsteady, then 1 2 3 dimensional flow, then laminar turbulent flow, uniform non uniform, compressible incompressible flow, and rotational irrotational. So first we will see the steady flow. So it is the steady flow means it is the type of flow in which fluid characteristics like velocity, density, pressure, these are not constant. Means these characteristics are not changed with time. Means they are constant with respect to time. And unsteady flow means the fluid flow in which the fluid characteristics like velocity, density, pressure, they are changed with respect to time. Means this is not constant with respect to time. Now uniform flow, it is the fluid flow type of flow in which velocity at given time does not change with respect to time, with respect to space. Okay, means mathematically we I expressed in dou v by dou t, means velocity at with respect to time is constant. And non-uniform flow means it is the type of flow in which velocity at given time change with respect to space. Okay, means dou v by dou t is not constant, it is change. So तो आप बोलेंगे स्टेडी फ्लो एंड यूनिफॉर्म फ्लो में क्या फ़र्क है? Both are same, but I will explain through one experiment. So in this diagram you can see the pipe. This is a inflow and this is outflow, and water flowing through this pipe. Okay, so I have I have certain point on this pipe, or we can say the 3 position on this pipe. Position A, position I have marked as position A, position B, and position C. So these position marked by alphabet, that is A, B, C. Okay, so I have to conduct one experiment, and point A, point B, and point C, these are the 3 different location on this pipe. Okay, so I have placed 3 student at first student at A, point A, and then second one is at B, and third one is at the C. So here is the table, and this table we have to conduct one experiment after some time interval, and we have to measure the velocity at point A, velocity B, and at point C. Okay, so first of all, if we measure the velocity at point A at time interval 0 minute, then we will get the velocity at a point A is the 1 millimeter per second. Then at B 3 millimeter per second, and at C 7 millimeter per second. After some time interval, that is after 1 minute, we will get velocity at point A is 1 millimeter per second, at B 3 millimeters per second, and at C 7 millimeter per second. After some time, that is after 2 minutes, velocity at point A is the 1 millimeter per second, velocity at point B 3 millimeter per second, and at point C 7 millimeter second. So from this table we can conclude that velocity with respect to time is not change, but with respect to space, with respect to point, means this is changes with point to point. Okay, so in the sense this velocity is a constant with respect to time, and with respect to space is changes. That's why this flow is the steady. Now this is same experiment we have to conduct for uniform. What is mean by uniform flow? So here same table, but velocity at, if we measure the velocity at time 0, that is a starting point, then we will get this velocity at point A is the 4 millimeter per second, velocity at point B is the 4 millimeter per second, and velocity at point C 4 millimeter per second. But after some interval, that is after some time, that is 1 minute, then we will get velocity at point A is 6 millimeter per second, at B 6 millimeter per second, and C 6 millimeter per second. After ending, after 2 minutes, then we will get velocity at point A 8 millimeter per second, B 8 millimeter per second, and C 8 millimeter per second. So from this table we can say, we can conclude, or we can observe that velocity will not change point to point, but after some interval this will change. Okay, means same with respect to space but different with respect to time. That's why this flow is the uniform. So I hope you understood between the difference between the uniform flow and steady flow. Means in the steady flow, this velocity with respect to time is not change, but with respect to space this will change. And here in a steady flow, in uniform flow, this velocity with respect to space is not change, but after some interval this will change. So now when we say this flow is the uniform and steady, so in this diagram we can say this velocity, we will get the velocity 1 millimeter second, this is a constant velocity after some interval and after some time, or after with respect to space. Means this is a constant with respect to space and constant with respect to time. That's why this flow is the steady and uniform. I hope you understood between the difference between the steady flow and uniform flow, and what is meant by steady flow, steady and uniform flow. Now laminar flow. So in this type of flow, fluid particles move along well-defined paths or streamlined, and all streamlines are straight and parallel. So from this diagram we can see that these all fluid particles move in straight line. Okay, so these particles move in laminas or layers, gliding smoothly over the adjacent layer. So this type also means this type of flow is also called as a streamline flow or the viscous flow. Now this is turbulent flow. This opposite to, totally opposite to laminar flow. So here these particles move, means they are not move in a straight way, they are move in zigzag way. Okay, so eddies formation takes place because of high energy losses. Okay, so how can we define this flow is the turbulent and this flow is the laminar? So here is the one non-dimensional quantity, that is we can say the Reynolds number. So this Reynolds number formula is the V d rho divided by neta. So here V is the velocity of flow rate, then D is the diameter of pipe, and rho is the density of fluid, and neta is the viscosity. So if this Reynolds, if we measure the Reynolds number and this is less than 2000, then this is called, this flow is called as a laminar flow, and if this Reynolds number is more than 4000, then this flow is the turbulent flow. But if we get Reynolds number is in between 2000 to 4000, then flow may be laminar or turbulent. Now compressible flow. So compressible flow means here density is not constant. Okay, so this will change point to point. So density notation is rho, but here I have used this j. So j is not constant, but incompressible fluid flow, here the density is the constant. Okay, means this not change point to point. So for I have mentioned a very good example. So gases are compressible fluid flow, but liquid are incompressible fluid flow. Now rotational fluid flow and irrotational fluid flow. So rotational means here the particles of fluid along streamlines, they rotate about their own axis. In irrotational fluid flow, these particles of fluid flow, they are not rotate about their own axis. That's why this is irrotational flow. Now 1, 2 and 3 dimensional flow. So one dimensional fluid flow means here the velocity is the function of only one axis, that is the x axis. Okay, it is the function of only one axis, and all means another one, that is y and z, both are constant. Okay, that's why this u, v and w are the velocity component in x, y and z direction respectively. Now two-dimensional fluid flow is the type of flow in which velocity is the function of time, and two rectangular space coordinate, that we can say x and y, means it is the function of x and y, and z is the constant. Now three-dimensional fluid flow means it is the fluid flow in which velocity is the function of all three coordinates, that is the function of x, y, z. I hope you understood about the basic concept about flow, then flow measurement, types of flow. If you have any question, then write in comment section. If you like this video, then like, share and subscribe to my channel. Thank you.